Today we're going to be learning how to find second derivatives implicitly. This first example, we have the equation x squared plus y squared equals 4. And I'm going to go ahead and give you the first derivative because I really want us to focus on second derivatives here. So my first derivative is equal to negative x over y. What's nice on these types of questions is often on the AP test, when they're asking you to find a second derivative implicitly, they'll actually tell you the answer that they're looking for. You just have to show the work that gets there. So in this case, we're looking for a final answer of negative 4 over y cubed. So let's see if we can get there. My first derivative is negative x over y. We're going to be finding the second derivative. And notice that my first derivative here is a quotient, so we need to use the quotient rule, which is g times f prime minus f times g prime over g squared. So g times f prime, which would be negative 1, minus f, which is negative x, times g prime, derivative of y, which would be dy dx, over g squared, in this case y squared. Now whenever we do these second derivatives implicitly, we're going to end up with a dy dx in our derivative. But we don't want it there. If you notice in our answer, there's no dy dx's. I'm going to replace that with what dy dx is equal to. In this case, negative x over y. So let's rewrite this, plugging in negative x over y for the dy dx. Here at the beginning I have y times negative 1, which is negative y. And then I have minus a negative x, so I'm going to say plus x times dy dx, which is negative x over y. And that is all over y squared. So notice we have a fraction in our numerator and then another separate term. I need to get a common denominator in the numerator so that I can combine those terms together. Now the only denominator that I have is y, so obviously I need to make the denominator on this first term y as well. So if I make that first term over y, then it's going to be negative y squared over y. And then my second term, I have a negative x here times x, so I'm going to make that minus x squared over y. And this is still over y squared. So all I've done here is gotten a common denominator of y in both of those terms. So I'm going to combine those together. Negative y squared minus x squared over y, and I'm going to multiply by the reciprocal of my denominator since I'm dividing with fractions. My denominator is y squared, or you could think of it as y squared over 1. So I'm going to multiply this times 1 over y squared times the reciprocal of the denominator. And I'm left with negative y squared minus x squared over y times y squared, which would be y cubed. Okay, that looks pretty simplified. Let's go back and look at the answer we were looking for. And you'll notice we've got the y cubed in the denominator. We've got that. But how in the world are they getting a negative 4? We have negative y squared minus x squared. And it says that they want the answer to be negative 4. If you're a real math nerd, you love this. And this happens a lot when you're finding second derivatives implicitly. Go back to your original equation, x squared plus y squared equals 4. And then look at what we have in the derivative, negative y squared minus x squared. So what I'm going to do is factor out a negative on the top, and that would make that y squared plus x squared. If I factor the negative out to the front, still over y cubed. And y squared plus x squared is equal to 4. So this equals negative 4 over y cubed, which is the answer that we were looking for. Let's look at one more example. In example number 2, y squared is equal to x cubed. And I'm going to give you that first derivative, which is 3x squared over 2y. We want to show that the second derivative is equal to 3x over 4y. So let's find our second derivative. Again, we have a quotient, so we need to do the quotient rule. Second derivative is going to be equal to g times f prime, 2y times 6x minus f times g prime, which would be 3x squared times 2 dy dx over g squared. And remember that squared needs to go for both parts of the term in the denominator. Now again, notice I've ended up with this dy dx, and so I need to replace that with what it is equal to. So let's do that and simplify a little bit in the process. 2y and 6x, I'm going to rewrite that as 12xy minus, I'm going to go ahead and multiply together the 3x squared and the 2 and get 6x squared times dy dx, which is 3x squared over 2y. And this is all over, I'm going to go ahead and multiply that out. We have 2y squared, which would be 4y squared if we square both of them. Distribute the exponent, which you can do when you're multiplying. You cannot distribute the exponent if you're adding. Sorry, I just had to say that. Okay, so now what can we do up here? We need to get a common denominator. But I think before I do that, notice that here we have a 6 and a 2 on the bottom. Let's simplify. Reduce that to a 3. So now my only denominator is y. The first term does not have a denominator. So I want to give the first term a denominator of y, which would make its numerator 12xy squared instead of just 12xy. We're going to multiply numerator and denominator times y so that we have that common denominator. Minus, I have 3x squared times 3x squared, which would be 9x to the 4th over y. And then this is all over 4y squared. So now we're at the point where we need to combine these two together into one fraction, the two terms that are in our numerator. At the same time, I'm also going to multiply by the reciprocal of the denominator so that we can end up with just one fraction. So 12xy squared minus 9x to the 4th over y times 1 over 4y squared. So that gives me 12xy squared minus 9x to the 4th over 4y cubed. And it seems like that's all of the simplification that we can do so far. Let's go back and look at our answer. Wow, we're looking for 3x over 4y, and I guess we have the 4, but we've got some extra y's, so we've got to figure this out. At this point, you should always go back and look at the original equation. In this case, y squared equals x cubed. Notice right here we have 12xy squared. But my original equation tells me that y squared is equal to x cubed. So let's change this y squared. I'm going to rewrite over here. Instead of 12xy squared, we're going to put 12x times x cubed because y squared equals x cubed in our original equation. So now on the top, I actually have 12x to the 4th minus 9x to the 4th over 4y cubed, which is equal to 3x to the 4th over 4y cubed. So now I'm getting closer. I've got that 3 there, which we were looking for, but I still have x to the 4th and y cubed. Well, again, and we could substitute either in the numerator or the denominator. y squared equals x cubed. I think what I'm going to do is substitute it in the denominator again. 3x to the fourth over 4. It is y cubed, but I'm going to think of it as y times y squared, and instead of y squared, I'm going to put in x cubed, because in our original equation, y squared equals x cubed. Now, the x cubed can cancel out 3 of those x's in the top, and I'm left with 3x over 4y, which is the derivative that we were looking for.